Okay, I'm recording now. Yes, I am. Yes. Hello, everyone. Welcome back to my channel. Before we continue with this ridiculous topic, I'd like to acknowledge my previous video and its insane performance. It's never been the case where I've gotten more than like 6k views in 2 weeks on a video before. Most of my videos, they're on 100, 200 views, but this last one that I posted about pizzas got 6k views. So all I need to do now is upload a few more bangers like that, and hopefully the channel will be more successful in the future. Anyway, let's see what this is all about. So the other day I was on Black Pen Red Pen's YouTube channel. If you don't know, he's a guy that does calculus, and he gave us the integral something like this. Whoops, let me just it was like this. So sine of x plus 2 cosine of x on the top, and 3 sine of x plus 4 cosine of x on the bottom. All of this in an integral. How do we integrate this? Well, doing it by parts, doing it by traditional methods is quite a nightmare. So instead he gave a very smooth sort of workaround. So he split the integral up into two parts, into two different integrals. This is not integration by parts, by the way. This is different. So he split it up like this. In the first integral, we have a, just an arbitrary constant which we will find the value of later. Lots of the integral of all of this. Of course, this integrand just cancels out to be 1, so the integral is just a lots of x plus b lots of the following integral. On the bottom we have the same denominator as we've always had. There you are. We still have the dx, but we will want the numerator to be the derivative of the denominator. So the derivative of 3 sine of x is of course 3 cosine of x, and that of 4 cosine of x is minus 4 sine of x. So that we end up with a lots of the integral of 1 dx plus b lots of all of this. Then of course you could do a u substitution, or the best way to think about this is that the integral of derivative of some function over that function is just equal to natural log of the original function plus our constant. So in other words, this is just b lots of natural log of the denominator. Technically we need absolute values instead of brackets, but yeah, there we are. There, and of course we have ax plus b log of all of that stuff, and then in order to find the values of a and b, we would do this. So I mean, it's just equating coefficients. You see this, all of this, the fact that the first line is equal to the second line implies that I'll just use a different color for now. There we are, red. So we have sine x plus 2 cosine of x is equal to a lots of 3 sine x plus 4 cosine of x plus b lots of 3 cosine of x minus 4 sine of x, right? So if we expand the left hand side a bit, 3a sine of x plus 4a cosine of x plus 3b cosine of x minus 4b sine of x, and then we can factor out sines and the cosines like this. 3a minus 4b lots of sine of x plus 4a plus 3b lots of cosine of x, right? And that being all equal to sine of x plus 2 cosine of x, right? This, via equating coefficients, would imply that sine of x equals 3a minus 4b sine of x, and that 2 cosine of x equals to 4a plus 3b lots of cosine of x. And then so what you do is you divide both sides by sine of x on the left hand side like this. You'd get 1 equals 3a minus 4b, and then on the right hand side you'd cancel out the cosines, and you get 2 equals 4a plus 3b, right? And then you just have a system of equations that you need to solve. I'll just rewrite them here. 1 equals 3a minus 4b, and 2 equals 4a plus 3b. There are many ways to do this. One satisfying way to do it is to take the first equation, let's multiply that by 3, not by 3, sorry, by 4, and then we end up with 4 equals to 12a minus 16b. And then we get the second equation, multiply that by 3, we get 6 equals 12a plus, that's a 3 by the way, plus 9b. And then what we would do is, we have 2 more equations, so equations 3 and 4, we'd subtract them from each other, so we get 4 minus 6 is minus 2, we get the 12a's cancel out, and we get negative 16b minus 19b, which is negative, I think, 25b. So that means 2 is 25b, so b is 2 over 25. And then, in order to find a, you do 1 equals 3a minus 4 times 2 over 25. And so 3a equals a over 25 plus 1, which is just 25 over 25 plus 8 over 25, or 33 over 25. And so a is just 11 over 25, and b is 2 over 25. And so therefore our answer would just be 11 over 25x plus 2 over 25 ln of absolute value 3 sine x plus 4 cosine of x, of course plus c at the end. Yeah, it's very nice. You see it's a very original method. I'd never thought about it before, and so that video really intrigued me. And when something piques your interest as a mathematician, what you aim to do, what my comment section aimed to do last time, is generalize, to come up with a general situation. So that's where my new sigma function comes in, truly for the sigma males. So the sigma function, denoted by lowercase sigma, not uppercase sigma, because uppercase sigma is it means a completely different thing. It's just a sum as n goes from one number to let's just say from j to k of some function of n. This just means f of j plus f of j plus 1 plus f of j plus 2 dot 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 all the way to f of k minus 1 to plus f of k, right? Where of course j and k are integers, right? So that's what the capital sigma sort of function is, but we're not talking about that today. We're talking about the sigma function, the function that I'm about to make. And this function is an absolute beast. Of course, I would have wanted to use Greek letters, but let's just use Latin letters for today. So sigma of A, B, C, D, let's say E, F. 6 variable. This is an insane function. If you wanted to graph this function with every single one of these variables, you'd have a 6-dimensional graph. But let's not talk about that. This would equal the integral of A sine x plus B cosine of x all over C sine x plus D cosine x dx. Of course, with our limits of integration going from e to f, like this, right? Now, using the method that Steve over at Black Pen Red Pen gave us to solve to compute a specific case where a is equal to 1, b is 2, c is 3, and d is 4, and e and f just don't exist because it's an indefinite integral. Now we have to generalize it using that method. So let's see what we get. Firstly, let's rewrite it as capital A, lots of the integral from e to f of c sine x plus d cosine x over c sine x plus d cosine x, right? So that our integral collapses to, our integrand collapses to 1, basically. It's just 1. Plus b lots of the integral from e to f of the denominator stays the same, yeah? That's what I already said earlier. And the numerator is just the derivative of the denominator. So derivative of c sine x is c cosine x. And the derivative of d cosine of x is negative d sine x, right? So that we end up with a lots of the integral from e to f of 1 dx plus b lots of the integral from e to f of c cosine x minus d sine x over c sine x plus d cosine x. I do realize that my c's can sometimes look like e's, so let me just fix that. There we are. Alright, and so this would end up being ax going from e to f plus b natural log of absolute value of c sine x plus d cosine x going from e to f as well, which would equal a lots of f minus e plus b lots of ln of c sine of f plus d cosine of f minus ln of c sine of e plus d cosine of e. By the way, when I say e, I don't mean Euler's constant. So apologies for this very flawed way of notating things. Perhaps I should have used Greek letters. I'm rejecting I'm really regretting my choice, but whatever, right? So we end up with af minus ae plus b times, well, this ln we can just combine it into one log using log properties. C sine f plus d cosine f over c sine of e plus d cosine of e, right? Once again, not Euler's constant. And then that would be our answer, except we would need to find the values of a and b, capital A and capital B, in terms of lowercase a, b, c, and d. So how do we find the values of capital A and capital B? So what we do is, based on the first two lines, we would infer that a sine x plus b cosine x is equal to a lots of c sine x plus d cosine x, like this. There we are. Plus b lots of c cosine x minus d sine x, like that, right? And then we would expand the right hand side, yeah, into a c sine x plus a d cosine x plus b c cosine x minus b d sine x. And then we would rewrite the left hand side again, boring, whatever, but we'd group the sines and the cosines with each other. AC minus BD, like this. Sine x plus AD plus BC, like this. Cosine x, right? And then from this we'd infer that A sine x equals AC minus BD. Of course, capital A lowercase c minus capital B lowercase d sine x. And also that lowercase b, cosine x equals capital A lowercase d plus capital B lowercase c cosine x. And then we'd cancel out the sines from both sides and the cosines from both sides. And so the system of equations that we'd get for this is that lowercase a equals capital A lowercase c minus capital B lowercase d, and also at the same time that lowercase b equals to capital A lowercase d plus capital B lowercase c, right? And it is very confusing. Once again, reminder, we need to isolate capital A and capital B and find those variables in terms of the other four lowercase variables. So in other words, isolate the uppercase whatever, right? So let's work with the first equation first. Let's toy around with it and see what we can do. Get it? C, AC minus, whatever. AC equals to BD plus A, right? So far we have that. That's just obvious. I just put the negative BD, added that to both sides, and got all this, right? That's simple. Now, we can then infer that capital A is just equal to capital BD plus A over C. And then we can go to the second equation and replace capital A with capital BD plus A all over C. And so we get lowercase b is equal to capital BD plus A over C. That's what replaced our capital A, and then D plus capital BC, like this, right? All I need to do now is isolate the capital B. So we have lowercase b minus BD plus A all over C multiplied by D is equal to BC. And if I divide both sides by C, I can isolate the capital B on its own. So that capital B is equal to B minus BD, let's say BD squared plus AD over C, and this all over C. And then I can split the fraction up, of course. Capital B is equal to lowercase b over C minus, wait a minute. Ooh, I made a little mistake. Yeah, my mistake was that I didn't realize that there was a capital B located here. I'm going to have to do this part again. Didn't realize that that's just a little blooper, so we're going to pretend that didn't happen. Yeah. So, what do we have? We have lowercase b equals, let me just split the fraction, b, capital BD squared over C plus AD over C plus BC, right? Now why don't I just multiply everyone by C like this, just to make things look a bit nicer and easier to work with. Then I can factor out the capital B from the right hand side like this, yeah, and minus AD on both sides, and then divide by D squared plus C squared on both sides. Of course I'll write the C squared first and then the D squared, because alphabetical order is just convention. And there we are. That's capital B in terms of our other four variables. And we need the same thing for capital A. So all I need to do is replace this with capital B over there, right? So that capital A equals to lowercase b C minus AD over C squared plus D squared. That's what our capital B was, multiplied by D plus A over C. And all I need to do now is just make this look nicer, right? So that capital A equals to BCD minus AD squared over C cubed plus CD squared plus A over C, right? And so there we have it. That's what our capital A value is, and then our capital B is over here. All we need to do now is go back to our original thing and replace our capital A's and capital B's with all the other stuff that we did. And by the way, comment section, if you notice a mistake that I make, please like pester me about it, because this is a big deal. If we're making such a big function, I'm bound to make I'm bound to make mistakes, and I need help. Even my voice is giving up at this point. Oh no, big disaster, my pencil, whatever. Okay, so let's replace capital A with, that's just a nightmare to write, B C D minus A D squared all over C cubed plus CD squared plus A over C. Okay, you know what? I'll keep it like this. That's A times F minus E, like that. Just so that it's not as much of a nightmare to write. And then let me just lasso select and move all of this stuff like that. Just over here, just to give myself more space. Perfect. All right. of course, plus b lots of our log of absolute value. Oh, I forgot to write b in terms of the other 4 variables. B was bc minus ad over c squared plus d squared, like this, right? And we have our log of absolute value of c sine f plus d cosine f all over c sine e plus d cosine e, right? And of course, because this is not an indefinite integral, we do have bounds. Those were e and f. We don't need the plus c at the end. And also, notice we don't have any x's in our answer. So that's why, if in case any of you are wondering, why didn't I put this x into the notation of the function, like sigma x? Why didn't I put x like that? Because in the terminology I would like to use is x in this case is a dummy variable. It's not a variable at all. It's just being used for the sake of the integral, right? And then once we're done our integral, we will replace x with e and f anyway. So x won't exist at the end, or it won't be present in the answer. Now let me just put parentheses around the inputs to the trigonometric functions at the end, just so that I don't confuse anyone. And I think that's done, honestly. Let me just go through the entire thing one more time again to verify that I'm not making any silly mistakes, and then, well, that's the end of the video basically, right? There we are. My software seems quite laggy today. Anyway, so that's what we started off with. Reminder: sigma of a, b, c, d, e, f, where a, b, c, d, e, and f they're just numbers really. The question is, do I restrict these numbers to the real numbers? Can I allow them to be complex? You know what, I'll allow them to be complex, because why not? So I'll write like this: a, b, c, d, e, f are in the set of all complex numbers. So in other words, the real numbers in the set of real numbers is inside the set of complex numbers, right? So that's one thing you got to understand. Just because they're complex, it doesn't mean a can't be just a basic number like 1, for example. It doesn't have to be 1 plus 2i. Anyway, we would need to talk about restrictions set on the bounds of integration, for example. We can't have e equal to f, because that would make our integral collapse to 0. But to be fair, our integral... Wait, would our integral be undefined? That's a question for the... Please, someone in the comment section, right? Is the integral from 0 to... from like a to a of some function, is this equal to 0 or is it undefined? Please, someone in the comment section. Like, someone, because... if it is undefined, then we are not allowed to let e equal to f. If it is defined as 0, then e and f can be the same. I don't mind. I don't mind if my function collapses to 0 for those bounds of integration. And of course, for those of you maybe starting out calculus, f is allowed to be smaller than e. F doesn't have to be greater than e. It just means that this is equal to all that, right? So that's just in case for some of you who are less affluent on the notation. Not that I'm fluent on the notation, I'm just saying. Okay, so there's no restriction at all on the e and f values unless the integral from a to a of a function is undefined. If it's defined as 0, no problem. How about restrictions on the a, b, c, and d values? Let's say, do we allow a, b, c, and d to all at the same time be equal to 0, for example? Well, that would make our integrand collapse to 0, and thus our entire integral as well. We could do that. I wouldn't mind at all. How about, like, I don't know. I don't think there should be any restriction on the a, b, c, and d values. As long as they're in the complex plane, that's fine, right? If there's a restriction on the e and f values, that's all we're concerned with. Now let's go on to the actual method, what I did, of course inspired by BPRP, black pen, red pen. So what I did was all this constant gibberish nonsense, c sine x plus d cosine of x, that was all good. The only part that I might have made a mistake on is this part over here. So I need anyone watching this video who, of course, is better than me at maths, anyone literally, to, if I've made any mistakes, then point it out, because I don't want my very nice, lovely 6-dimensional function to be ruined because I forgot to do something. Alright, so I equated this a lots of c sine x plus d cosine x plus b lots of c cosine x minus d sine x to a sine x plus b cosine x. That was the first line in this bit of my working out is fine. The second line seems to be fine as well, and the third line is just me factorizing stuff. That's fine. My fourth line is just me cancelling out the sine. Oh, by the way, any of you wondering, hey, what happens if sine of x and cosine of x are equal to 0? You're not allowed to cancel them out like this, are you? Well, given that I'm using the x's as dummy variables and that they're not actually being changed or anything, I'm technically allowed to do this. It's not the best explanation I can give, but someone in the comments can, of course, clear up. Anybody who does programming or higher level calculus than me, then, you know. Anyway, so this line of working here was, I think this is correct for now. I haven't made a mistake yet. Well done me. This reshuffling that I did over here on this left hand side of the screen, that was quite beautiful. I'm very happy with what I did there. And so what I did was I went back over to the second equation, replaced capital A with capital B D plus lowercase a all over c, and then I think I expanded some stuff out. I also split the fraction going from here to there. The fraction b d plus a all over c, I split it up and multiplied everything by d all at the same time. That was quite smooth. Then I multiplied everything by c. That was quite good. I remember that. No mistakes so far. Then I factored out the capital B and just isolated it in the simplest way that I could. And there's no mistakes there in me getting the value for capital B. I'm happy with that. How about me getting the value for capital A? Is that part of, because that felt a bit, you know, it's just an intuitive feeling that I made a mistake. I don't know if I actually did. So BCD minus, so now we're looking at this area of the screen now, right? The rest is correct, right? A equals BC minus AD, blah blah blah. I expanded out the D into the brackets, and I think, oh yeah, I had the C on the denominator over here, and so what I did was I split the fraction up as well. Perhaps it's best maybe that I keep everything, you know, in one line. I think it just looks nicer, you know. So instead of writing it like this, I'll write it like this. Let me just c squared plus d squared plus a like this, all over c like that. I didn't change anything. I just expand, you know. It's not like I'm correcting my mistake. I'm just making things look nicer. Then what happens if we were to I don't know, say multiply the numerator and the denominator by c, right? Actually no, that wouldn't do anything with it, no. Maybe divide. Well, I don't think I should be doing that. Is there any other way to, oh yeah, what if I multiply the numerator and the denominator by c squared plus d squared, in order for me not to have a fraction within a fraction, just to make my function look as polished as possible. So I would end up with this. Like this, right? Okay, it looks worse now. It looks worse. Okay, I'll keep my sigma function intact. So my capital B value, this looks fine. I'm not changing this. But my capital A value, I think this is the final state, which I'll leave it at. So what did I do? Let me just rub this out and replace it with the nicer looking version. Same thing, not just nicer. BCD minus AD squared over C squared plus D squared. This plus A, and then the entire thing all over C, like that, right? That's what I want it to be. Technically, I could also put this C over there, like this, right? It doesn't change anything whatsoever. It just, what I mean is this, right? I could technically do that, and that actually looks elegant. It doesn't really matter in that situation. I'll just put the C over here, just for you to see like that. Okay. Everything else is fine. I'm happy with my function. So, in other words, sigma of A, B, C, D, E, F is equal to all of this junk, right? And there we are. That's my sigma function. Should I write it nicely in one line at the very end, just to make the video feel more climactic than it actually is? Sure, I'll just rewrite it here. Sigma of A, B, C, D, E, F is defined as the integral going from e to f of A sine x plus B cosine x all over C sine x plus D cosine x dx, which according to our computations and all that was equal to BCD minus AD squared over C squared plus D squared. Oh man, you can see my handwriting disintegrate. Whoops, why is my keyboard there? Okay, AD squared over C squared plus D squared, like this, plus A all over C, like that, multiplied by F minus E, of course. Okay, like that, plus whatever we got for the value of capital B, which is BC minus AD over C squared plus D squared, times the natural log of C sine F plus D cosine F over C sine F plus D C sine E plus D cosine E, like this. Right, there we are. This is actually very nice, and I think it's done. Maybe we should leave it in this state. Technically, another thing you could do is put this, our value for capital B, as the exponent inside the log, but I think it looks nicer in this state. I don't like having... Alright, that's fine, I think. So there we are. This concludes our video. Thank you for watching. I hope you enjoyed this, and perhaps it opened up your eyes. And please don't tell me to draw a graph, right, with all these variables. I will literally die, right? I'm not. I can't do that. That's where my limits end. I can't see beyond the fourth dimension. You know, doesn't work. Okay. Okay. Finally, A, B, C, D, E, F are all in the complex plane. Can E and F be complex values? Well, I don't see the issue with that, because technically thinking of integrals as areas and volumes, depending on the number of variables you're integrating under, is not the only way to think about integrals. You don't have to think about them as areas, right? So, given that, having E and F as complex numbers, I don't see the issue at all, right? So there we are. That's my sigma function. I hope you have a nice day and can continue all of your side hustles and your grinds. Have a good day, and make sure to wake up at 4 tomorrow.